All right, welcome back. Lesson 2 of week 4, and we are going to just go over a skill today. And this skill is going to be used next week when we get into adding and subtracting rational expressions that do not have a common denominator. So the skill that we need to learn is how to find a common denominator. And when I say common denominator, I mean the least common denominator, or the LCD. It's relatively easy to find a common denominator with fractions. So like in this warm-up, we have the fraction 1 over 8 and then 3 over 22. And it would be relatively easy to find a common denominator if we just multiply the denominators together. So if we just did 8 times 22, we would find a common denominator. However, that is not going to be the least common denominator. Sometimes it might be, but not always. So the way we're going to find the common denominator is we're going to take each one of these fractions and we're going to factor the denominator. So we're going to take the 1 over 8 and write it as some numbers that multiply to equal 8. So we know we can write it as 2 times 4, and that is a unique factor, right? Okay, so I'm going to leave this one like this, and then I'm going to go over to the other one, and I'm going to write this as 3 over 22, and then I'm going to factor the denominator and write it as 2 times 11. And then to find the actual least common denominator, what we want to do is we want to look at the factors that we have there. And you'll notice that we have a 2 and a 4 in the first one, and we have a 2 and 11 in the second one. And so what we're going to do is we're going to take all of the unique factors once, all right? So what I mean by that is, like, if I highlight this 2 here, I'm not going to highlight the 2 over in the other one, but I am going to highlight this 4, and I'm going to highlight the 11. All right, so then the least common denominator for these two fractions is going to be those 3 things multiplied together. So 2 times 4 is 8, times 11 is 88. So we're going to have a least common denominator of 88. And so I'm going to write those here. And then the tricky part is, well, what did I have to multiply 1 by to turn it into the 88? So what do I have to multiply 8 by to turn it into 88? Well, I had to multiply it by the 11, right? So that means I have to multiply the numerator of this one by 11. In this case, it just equals 11. So this is 11 over 88. Okay, and then with the other one, this is where it gets maybe a little bit trickier. So I multiplied the first one by 11, and you might look at this and say, oh, I'm going to multiply this other one by the 2 and the 4 because that's what's highlighted over here. Well, we don't necessarily want to do that because we only want to multiply it by the unique factor. So the unique factor is 4. There's already a 2 in the other one, so we only want to multiply it by a 4 because 22 times 4 gets us to 88, right? So we have to multiply the 3 times 4. And so this is where it gets a little bit tricky. And so we end up with 12 over 88. Okay, so the least common denominator is the smallest number that 2 or more numbers can divide evenly. Okay, and when finding the least common denominator with expressions it's a little bit different. What we're going to do is we're going to factor each denominator completely using exponents for the same factors. And then we're going to circle the unique factors with the highest exponent. Circle, highlight, whatever we want to do. And then the LCD, or the least common denominator, is the product of those unique factors. Okay, so what does that mean? Well, I think it's easiest just to kind of put it to work and see what we have. So what I'm going to do is I'm going to take these two fractions and I'm going to factor them. The first one is already factored, so I just wrote it as 5 times x. And the second one we can write as 5 times 3 times x squared. And then what I'm going to do is I'm going to take anything that's unique. All right, so 5, and I'm only going to highlight one 5, and then I'm going to highlight the 3 because it is definitely unique. There's no other 3, right? And then with the x's, instead of taking both of those x's, what I'm going to do is only highlight the one that has the highest exponent. So in this case, it's that one right there. Okay, so my LCD in this case, the least common denominator, is 5 times 3 times x squared, which ends up being the denominator of the second fraction. And sometimes that's the case. Sometimes the case is where we have the least common denominator is the same as one of the denominators, and that's okay. And so now if we were to write equivalent fractions now, let's not worry about that now. We're going to do that later, actually. So let's just worry about getting the LCD down. So we got the LCD, all right? So it's the unique factors and then the smallest exponent of any common factors. Okay. All right, let's do another one. Hold on, let's see here. Well, these aren't too bad. I should have had more like the other ones, but that's okay. So sometimes we don't have to do a whole lot, and if we zoom in here, we can see that we have two unique factors here. This is unique, this is unique. So my LCD is actually just those two things multiplied by each other. So we have the LCD is just x plus 2 times x minus 2. Okay? Sometimes it's pretty quick and simple like that. Now, and you might be wondering, well, what about highlighting just a 2 or a -2 or an x? Well, remember, binomials are considered one thing. They're connected together by the plus or minus sign, so we can't separate them. So we can't pick individual parts of these out. Okay. Similarly with this one, we have a unique factor in x, and then we also have a unique factor in x plus 4. So our LCD is just x times x plus 4. And you'll notice I'm not actually multiplying them together again. I'm just leaving them in the form that they're in because we want things simplified, because ultimately we're going to end up trying to cancel stuff at some point. Okay. Oh, here we go. This is good. We're going to see some more stuff here. All right. So those first 3 were relatively straightforward. The second 2 were very straightforward because all we had to do was multiply things together. But in this case, I'm going to rewrite these fractions and I'm going to factor the denominator. So this is where we have to be really kind of good at factoring stuff. So I have 6m squared from the first one, and then with the first denominator I can factor out a 3. Okay, and the second one, I am just going to leave the second one as it is, because technically it's already factored, but it just has an exponent of 2. So this is where we kind of have to go through our little list of rules. We want to circle all the unique factors, or highlight. So there's a unique factor. 3 is unique, right? Now the m plus 5, we have m plus 5s in both of them, but we don't want to take both of them. We only want to take the one that has the highest exponent. And in this case, the highest exponent is that one. And so our LCD is 3 times m plus 5 squared. Okay. All right, let's keep going. See what else we got. Ooh, lots of factoring here. All right. So some of you might be tempted to like, oh, I need to simplify things. We're not simplifying at this point. All we're doing is finding a least common denominator. So again, I'm going to factor the first fraction. So we have t minus 10 over, and this is going to turn into two binomials, right? And this is one we just kind of have to think about. So we're going to have t plus 2, t minus 3. Okay, and then the second one we can write as t plus, what? Don't do that. All right, t plus 5. My hand bumped the screen is what happened. Okay, so we have two binomials down here on the bottom, and so we're going to have t plus 1 and t plus 2. All right, so this one, we want to circle or highlight anything that is unique, and that's going to become part of our LCD. And so when I say unique, even if something shows up more than once, you're going to highlight it. So I'm going to highlight that, and I'm going to highlight that one, and I'm going to highlight that one. But I don't need to highlight the other t plus 2 because I already highlighted one. Okay, so we're only going to take things once. We don't ever want to take something twice unless we have something like this where we have an exponent of 2. So then we would take it twice, all right? So that's why we always highlight the unique things, and then if there are common things, we take whatever has the highest exponent. Well, in this case, the t plus 2s, they have an exponent of 1, so we're just going to take one of them. Okay, so our LCD in this case is t plus 2, t minus 3, and t plus 1. And, you know, again, I'm going to leave that like that for my LCD because eventually I might be able to cancel some things. So I'm going to leave that until the very end to mess around with further. Okay, here's another one. So we're going to do 2 over x minus 2, so that one doesn't change. But then this other one changes because we don't like to have stuff that's backwards, so we change the order here, right? And we factor out a negative 1. Whoops, not plus, that should be minus. Minus 2. Okay, so we have negative 1 times x minus 2. Okay, so, you know, now you might be looking at this and saying, well, one's in parentheses, one not. Does that make them different? No, we can put that in parentheses too. They're the same. So that's unique. You know, we have 2 of them, but we're only going to take 1. And then that is unique. So our LCD, whoops, I don't want to write with that. LCD is negative 1 times x minus 2. Okay, so we're just taking the unique factors and multiplying them together to make the LCD. All right. So here we go. This is what I started to do on the first one, but then I was like, no, let's wait. All right. So once we have our LCD, then we're going to have to do some work. We're going to have to take our LCD and use it as the denominator for each of the fractions, but then we're going to have to figure out, okay, if I use that for the denominator, I have to multiply the numerator by whatever I did to change the denominator. So these examples down here are going to help us start to see what is going on and how we actually can do that. So the thing we need to think about here is, what did I do to 9b to turn it into 27a squared b? So this is like saying, all right, our new least common denominator is 27a squared b. So, well, what do I have to do to what did I do to the 9b to turn it into that? And then I'm going to do the exact same thing to the numerator to turn it into that. Well, if we just think about it, 9 times 3 is 27, right? And then there's no a squared with the 9b, so we know we have to multiply by an a squared. And there is a b there, so we don't have to multiply by another b. So we need to multiply 9b by 3a squared to turn it into 27a squared b. So we have to multiply the numerator by this same 3a squared. So we're just going to say, all right, this right here is going to be 4b times 3a squared. So my equivalent fraction now is 4 times 3 is 12, right? And then we have a squared b. Okay, so I just created an equivalent expression. And so this is something that's really important. It's something that we're going to have to do when we create common denominators. We're going to have to do this to the numerator of the fractions that we're dealing with so that we can add or subtract them. Okay, so let's look at another one. So the question here is, what did I do to 2x plus 5 to turn it into 6x plus 15? And well, if we think about it, 2 times 3 is 6, 3 times 5 is 15, so I multiplied this by 3. So what I need to do to find the numerator here is just take 7x and multiply it by 3. I don't know why I wrote that multiplication sign. Let's not do that. So we end up with 21x. Okay, so I just created an equivalent fraction by multiplying by 3. Hopefully you're getting the hang of this. Now these are the trickier ones, because what do I have to do to multiply this to turn it into that? Well, jeepers, they don't look anything alike, right? But the thing I want to think about is I'm going to come down here and I'm going to factor this thing, x squared minus 4. Anytime we see something that looks like that, we know it's x minus 2, x plus 2. So now the question is much more obvious. The answer is much more obvious. What I have to multiply this thing by to turn it into the denominator there, well, I have to multiply it by x minus 4, right? So I'm needing to multiply by x minus 4. So this is what I need to multiply the numerator by. And so it ends up becoming fairly simple once you identify it. And the hard part is just identifying. So we're just going to take 5 times x minus 4. Well, that's just 5 times x minus 4. Okay, so there's our new numerator. So, and the key thing to notice is the only thing that changed about the denominator was this. So the only thing that changes about the numerator is we multiply by that as well. Okay, do we have more? Or is that it? That is it. So let me look at the assignment here and see if there's any crazy stuff that we need to worry about. So with these here, oh shoot, I don't have any like those for you to do. All right, here. Let's just practice finding the LCD, and then next week we are going to worry about multiplying to figure out what the new numerators are going to be. So just find the LCD for these. So really you only have to worry about the denominators with these. Don't worry about the numerators. If you want to try some of these numerators and see if you can figure out what the new numerator is, that's perfectly fine if you want to do that and get a little practice before next week.